I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are discussing solutions of some very interesting questions from examination point of view. My student Amy has selected these questions. We'll first understand their solutions with Amy, and then I'll provide you with complete solution. Let us now understand and solve the problem.
So figure 2 shows a sketch of part of the curve with the equation y equals 5 cos x minus 30, where x is greater than or equal to 0. The point P on the curve is the minimum point with the smallest positive x coordinate. State the coordinates of P.
Correct. So the maximum starts with 30. That means the graph is shifted 30 units to the right. Minimum normally will be half the period, right?
Yeah.
So half of 360 is 180. So
180
plus 30, correct?
So 210.
210. So state the point P. P is at 210 because that is where the minimum will shift, correct?
And this times 5. So would it be minus
Times 5. So this is
5.
minus 5 and that is plus 5, correct?
Yeah. So
Yeah.
210 minus 5.
210 degrees and minus 5 value, correct. Next.
Solve for x between 0 and 360, giving your answer to 1 dp. So that was nice because I just used, the cos double angle formula.
Okay, compound angle formula. Yeah.
Compound, sorry. Yeah.
And
A plus B and the minus, and then I just isolated the terms and worked through it.
Correct.
I am Anil Kumar. Welcome to my series with Amy. We are discussing very important examination questions as she is preparing for her final exams. These questions are selected by her. We'll see how do we solve them. The question before us is regarding the function y equals to 5 cos of x minus 30 degrees. Graph is shown. In part A, we need to find the coordinates of point C. We need to find the coordinates of point P, which is the minimum, the very first minimum for this particular graph. We can see that the cosine function is shifted right by 30 degrees. Normally, for 5 cos of x, the minimum will be at 180 degrees and the value will be minus 5. Now, the function is 5 cos x minus 30 degrees. That means it has shifted 30 degrees to the right, correct? All the points here have shifted 30 degrees to the right. Also the minimum, and therefore the point should be 180 degrees plus 30 degrees, and the value will remain as minus 5. So it is at 210 degrees that we get a minimum value of minus 5, and that is how we can write down the coordinate of point P. Now let us see how do we solve the equation, which is 5 of cos x minus 30 degrees equals to 4 sine x. So let me take this solution now within the domain 0 to 360 degrees, 0 included, 360 is not included. So if I kind of graph it, how will it look like? Just to give you an idea, since this is 5 or minus 5 maximum minimum, for the sine x, it will be 4 will be the maximum value. We want to find the solution for 5 cos of x minus 30 degrees equals to 4 sine x. If you graph it, well, sine will have minimum, and dividing this into 4 equal parts, we get the graph which will go to maximum, then a minimum, and then a maximum, which will be kind of like this, right? In fact, let me just say that this is actually 360 plus 30. This is 390. 360 will be somewhere here. And therefore, we can say that that is going to be a 0. It will go to the maximum. And then it will, that is the center. So it will be kind of like this. In that case, we see that we'll have two solutions. So you get an idea that we are expecting two solutions. Let us find out these solutions. Best way is expand. So 5 cos x minus 30 can be written as 5 cos of x cos of 30 degrees plus 5 sine of x sine of 30 degrees equals to 4 sine x. Well, as far as 30 degrees is concerned, let us look into the right angle triangle 30, 60, 90. And write down the values. So we have 5 cos x, cos of 30 is square root 3 over 2, plus 5 sine x, sine of 30 is half. And that should be equal to 4 sine x. We can simplify this writing 5 square root 3 cos x over 2 should be equal to 4 sine x minus 5 by 2 sine x. And that gives you 8 minus 5 as 3. So we get 3 sine x over 2. And on the left hand side, we have 5 square root 3 over 2 cos x. So well, dividing by cos x, we can write this as tan x equals to 5 square root 3 over 2 times 2 over 3, right? So that gives you 2 and 2 cancel. We get 5 over square root 3. And so x is equals to tan inverse of 5 over square root 3. So that will be one value, which will be this one. And then we can add 180 degrees to get the other solution. You get the idea. So that is how we will get two solutions for the given equation. Perfect. So the calculations have been done for you right there. So we have this calculations done. The question being 5 cos of x minus 30 equals to 4 sine of x. We need to find the solution from 0 to 360 degrees. When you expand the left hand side and bring the terms together after placing the value of sine 30 and cos 30, we do get tan x as 5 square root 3 over 3, and tan inverse gives you the answer as 70.9. And when you add 180 degrees, you get 250.9 degrees. So these are the two solutions which we find for the given equation. Now in part 2, there was another question. Let's look at this question. And that says that deduce, giving reasons for your answer, the number of roots for the equation. Let me enlarge this. 5 cos 2x plus minus 30 equals to 4 sine 2x within the domain 0 to 3600. Now, we have two solutions when we are looking into the previous equation. And now what has happened? Can you tell me how will the number of solutions change? Since we have cos 2x and sine 2x, we have horizontally compressed the waves by half, and therefore we'll have two solutions in 0 to 180 degrees, 4 solutions in 0 to 360 degrees, and times 10, which is 40 solutions when we talk about 0 to 3600 degrees. You get the idea. And therefore, for part B, if you are looking into the domain from 0 to 3600, we expect 40 solutions. So I hope this concept is absolutely clear. So with that, we can solve this question. In case you have any questions, feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.